Hello and welcome to my channel, The Curious Coder. Today we'll be talking about something that is given a very special treatment by Java developers, strings. Over the years, developers have added so many unique features to strings that interviewers just can't resist asking questions around them. And these questions can come from literally any angle. It could be how they are stored in memory, string pooling, immutability, their methods, performance. So you never know what's coming. So in this video, I've made sure to cover all the important topics and turn them into creative questions. We have MCQs, match the following, output based questions, everything. And of course, every question is filled with simple visuals and diagrams, so it is super easy to follow. Alright, so let's not stretch this and jump straight to question 1. Question 1, match the following. In the first column, we have string, string buffer and string builder, and we need to match them with their respective characteristics. Mutable means once created the value can change. Immutable means that it will not change. Thread safe means it can be used safely when multiple threads run at the same time, and not thread safe means that it may break or behave incorrectly in such situations. So string is immutable as well as thread safe. That means once created, its value will not change and it is safe to use a string in a multi-threaded environment. String buffer is mutable but still thread safe. That is, you can change a string buffer value after its creation and you can use it in a multi-threaded environment. String builder is mutable and not thread safe, which means you can change a string builder as well, but it is not safe to use it in a multi-threaded environment. Okay, question 2. Guess the output of the following code. We are given a string s1 is equal to hello and we are performing concatenation on s1 using s1.concat world. Then we have a string builder s2 is equal to new string builder hello and we are appending world into it by writing s2.append world. Similarly, we have a string buffer also, string buffer s3 is equal to new string buffer hello and we are appending world into it by writing s3.append world. Then we are printing s1, s2 and s3 one by one. Okay, so we need to guess the output of this code. So the output will be hello, then hello world and then hello world again. This is because string is immutable but string buffer and string builder are not. So initially inside the memory, s1, s2 and s3, all three of them will be pointing towards three different hello. When we perform append on builder and buffer, the same value gets updated and it becomes hello world. But in case of a string, when we perform concatenation, hello world gets created in the memory. Yes, but not at the same location. It does not change the original string and s1 is still pointing towards the original location. That's why hello gets printed. Okay, this is what immutability means. Even if you try to concatenate a string, the original one remains intact. Question 3. Guess the output of the following code. We are given with a string s1 is equal to hello and we are doing s1 is equal to s1.concat world and then we are printing it. So this time the output will be hello world. Again, initially in the memory, s1 is pointing towards hello. After concatenation, hello world gets created at a different location, but in this case, we are doing s1 is equal to s1.concat, which means we are explicitly changing the pointing of s1 to hello world location. So the string was still immutable because hello is still there at the same location and its value is not changed. But the pointing of the reference variable s1 was changed and hence hello world was printed. This is a classic confusion case when we study about immutability and every developer must get this clarity. Okay. Question 4. What is string constant pool? Now string constant pool is a special memory area designed only for strings. There are two major points to learn about the pool. First is that this pool is present inside the heap memory and second, duplicate values are not allowed inside the pool. Now the string constant pool is not the only location where strings are stored. Let's move on to the next question to understand how strings are stored in memory in much more detail. Now question 5, it's an MCQ. In which of the following memory areas are strings actually stored? A. Stack memory, B. Heap memory, C. String constant pool or D, register memory? So the correct answer is B and C, both heap memory as well as the string constant pool. When you create a string like this, string city1 is equal to Delhi, it is called a string literal and it gets saved in the pool with city1 variable pointing towards it. But when you create a string like this, string city2 is equal to new string Hisar, then it's called a string object and it gets saved in both the pool as well as the heap memory. Why? Because when you use a new keyword, Java considers it as an object and objects are always saved in the heap memory. But it is also a string, so that's why it's saved in the string constant pool as well. However, in this case, city2 will be pointing towards the 1 in the heap memory. This is how strings are stored in the memory internally. Okay. Question 6. There are 3 string literals S1, S2 and S3 and all of them have value as Shivam. You need to guess how many string values are stored inside the heap memory and how many are stored in the string constant pool. So the correct answer is, inside the heap memory there will be nothing stored because these are string literals and not objects. And inside the pool, only one copy of Shivam will be stored, to which S1, S2 and S3, all 3 of them will be pointing. This is how string constant pool works. It does not take any duplicates. So once you add a literal in it, the same one can be reused. And that is the main logic behind having the string constant pool. It saves memory. Question 7. There are 3 string objects S1, S2 and S3 and all of them have value as Shivam. Now you need to guess how many string values are stored inside the heap memory and how many are stored in the string constant pool. Now this time these are objects, so 3 different Shivam will be created inside the heap memory. S1 will be pointing towards the first one, S2 towards the second one and S3 towards the third one. And a corresponding Shivam will also be made in the pool. But in the pool, it will only be created once and no reference variable will be pointing towards it, because in case of a string object, they point towards the copy in the heap memory. Okay. Now question 8. Why are strings immutable in nature? Immutability ensures that strings can be safely reused without unexpected modifications. Let's say there are 3 string literals, string city1 is equal to Delhi, string city2 is equal to Delhi and string city3 is equal to Delhi. According to the concept of string constant pool, all 3 of them must be pointing towards Delhi, right? Now let's say we change city2 to Pune. Now if strings would have been mutable, then Delhi would have changed to Pune and city1 and city3 will also point towards Pune. But this is not right. Let's say there are thousands of string variables pointing at the same literal. A single change in the literal will cause change for all. So to avoid that, strings were made immutable. When we make city2 is equal to Pune, a new literal is created in the pool and city2 points towards that. But the original location still holds Delhi, to which city1 and city3 are pointing. Question 9. What is the difference between equal to and dot equals when we compare strings? So the answer is that equal to compares the address of the string and dot equals compares their values. It means that if 2 string references are pointing at the same location, then equal to will return true, else it will return false. It does not matter whether they have the same value or not. Similarly, if 2 strings have exactly the same value, then dot equals will return true, else it will return false. It does not matter whether they are at the same location or not. Question 10. Guess the output of the following program. We have a string s1 is equal to new string hello and we have another string s2 is equal to new string hello. We are first comparing them using the equal to operator and we are printing the result. Then we are comparing them using the dot equals method and we are again printing the result. So the output will be false and then true. This is because both the strings are created as objects. Hence they are stored in the heap memory at 2 different locations. So equal to will return false, but they do have the same value hello and hence dot equals will return true. Question 11. Guess the output of the following program. We have a string s1 is equal to hello and we have another string s2 is equal to hello. Again we are comparing them using the equal to operator, and then we are comparing them using dot equals method. Now this time the output will be true for both. This is because the strings are created as literals and they both have the same value. So only a single literal hello will be saved in the string constant pool, and both s1 and s2 will be pointing towards it. Now they both are pointing at the same location, hence s1 equal to s2 returns true, and they anyways have the same value, so dot equals will definitely return true. Okay. Question 12. Guess the output of the following program. We have a string s1 is equal to hello, and we have another string s2 is equal to new string hello. And again we are comparing them using equal to operator and then using the dot equals method. Now this time the output will be false and then true. One is created as a literal and another one as an object. So s1 will be pointing towards the one in the pool and s2 will be pointing towards the one in the heap memory. Hence they are pointing at two different locations, which means that equal to will return false, but they do have the same value, so dot equals will return true. Question 13. We have a string s1 is equal to new string hello. We make s1 is equal to null. Now will the string value be deleted from the memory? So the answer is no, not at first. When we make s1 is equal to null, we say that s1 is now not pointing anywhere. But it does not mean that the string which resides in the memory got deleted. It means that the string is now sitting idle with no one pointing towards it. However, there is a cleanup process in Java called garbage collection. It runs from time to time and it cleans up all the unreferenced objects. So at the time of garbage collection, the string object will get deleted eventually because it is unreferenced. Question 14. We have a string s1 is equal to hello and we make s1 is equal to null. Now will the string value be deleted from the memory? Again, the answer is no. It will not be deleted because we have just removed the reference and not deleted anything. But in this case, the string literal will not be deleted even when the garbage collection takes place. That's the beauty of the string constant pool. It keeps any literal stored inside it safe with the hope of it being reused somewhere in the future. So you can assume that even though it's not being pointed by any reference variable, it's still pointed by JVM internally and hence it won't be deleted at the time of garbage collection. Question 15. What is wrong with the following code? We have a string s1 is equal to hello. Then we make s1 equal to null. And then we are performing a concatenation operation on s1 by writing s1.concat world. And in the end we are just printing s1. So the answer is that this code will give a null pointer exception. You first set s1 to hello, but then you immediately assign null to it. So now s1 doesn't point to any string. It's literally pointing to nothing. So when you do s1.concat world, you are saying that first it should go to the location where s1 is pointing to. It should fetch the value that is there at the location, add world to it, and then save that new string in the memory. In an ideal world, it will work, but this time your variable s1 is not pointing towards any location. So how will this work? Hence Java throws a null pointer exception. In simple terms, you can never call any method from a reference variable which is null. It will always result in null pointer exception. Question 16. Guess the output of the following program. We have a string s1 is equal to new string Shivam, and we have another string s2 is equal to new string Shivam. We are comparing these two strings using the equals method. Similarly, we have string buffer s3 is equal to new string buffer Shivam, and another string buffer s4 is equal to new string buffer Shivam. Again, we are comparing these two using the equals method. Similarly, we have two string builders s5 and s6 and their values are also Shivam, and we are comparing them with dot equals method. Now the output will be true, then false, and then false again. Why? We compared them with dot equals. Why is it false then? The values are same. So this is another concept that we must understand. Equals is a method of the object class. Okay, object is the parent class of all the classes in Java. Now string class has overridden this equals method and given its own implementation. And in their implementation logic, they loop on every character of the string, compare each character, and if they are same for both the strings, then it returns true. In short, if both the string have same value, then dot equals will return true. But string buffer and string builder have not overridden this equals method in their respective classes. They have given no implementation of their own. So when we compare them using dot equals, the object classes method gets invoked. And in the object classes method, there is a default implementation that actually compares using equal to equal to. Okay, so it does not compare the values, and that is why we got false printed, because S3 and S4 are at different locations, and even though we are calling the equals method, but eventually equal to is getting used, which will return false for different locations. So for any class that does not override the equals method, the object classes equal method will be triggered, which will eventually compare the addresses. Okay. Question 17. Explain the internal working of concatenation for the below code. We have string A equal to hello, string B equal to world, and string C is equal to A plus B. So we are concatenating two strings and we need to tell the internal working of concatenation. Okay. So now concatenation means that adding something in a string. In this case, the concatenation will take place at runtime, not at the compile time. This is because we are adding two variables and the actual values of A and B will only be known at the runtime. So internally, Java will be using string builder to concatenate, and the code will translate into something like this. String C is equal to new string builder dot append A dot append B dot toString. Basically, whenever we concatenate two strings using variables, Java internally creates a string builder first. It appends those two strings and eventually converts them back to string using the toString method. And all this is done at runtime, not the compile time. The final result will be saved in the heap memory. So this is the internal working. Question 18. Explain the internal working of concatenation for the below code. We have string S is equal to hello plus world. Now this time the concatenation will take place at compile time. We are concatenating two string literals directly and their values are already known at the compile time. So no string builder is created, no conversion takes place, both the literals are added together at the compile time and the final result hello world gets saved in the string constant pool. Okay. Question 19. Explain the internal working of concatenation for the below code. We have string S is equal to age plus 20. So this time we are adding a number to a string. So internally, Java will have to convert this number into a string. Again, this happens at runtime using a string builder. The code translates into something like this. String C is equal to new string builder dot append age dot append string dot value of 20 dot toString. Basically, a string builder is created. It appends age into it. Then 20 is converted into a string using string dot value of method. It is then appended to the builder and in the end the result is converted back to a string. This result will also be saved in the heap memory. Question 20. Guess the output of the following program. We have a string S1 is equal to 10 plus age. String S2 is equal to age plus 10 plus 10 and a string S3 is equal to age plus 10 plus 10 inside parenthesis. Then we are printing S1, S2 and S3. So the output will be 20 age, then age 1010 and then age 20. This is because Java computes from left to right. In the first case, both 10 will be added and become 20. Then they are concatenated with age. At the time of concatenation, they get converted to string. So the final output becomes 20 age. But in the second case, age is first concatenated with 10, thereby converting 10 into a string and making it age 10. Then age 10 gets concatenated with 10 again, and again 10 gets converted into a string, and the final result becomes age 1010. In the third case, age is concatenated with the result of 10 plus 10, because parentheses are used. Hence it becomes number 20, which is concatenated with age, making the final result as age 20. Question 21. Match the following. On the left side, we have different string operations that we can perform, and on the right side, we have time complexities. Now we need to match the operations with their respective time complexities. So char at I fetches a character using index, so it takes O of 1 time. Length also takes O of 1 time. Equals compares the characters one by one, so time complexity will be linear, that is O of n. Concat creates a new string with each character of the old string plus the one which is appended. So again the time complexity is O of n. Now substring is used to extract a smaller part of a string. After Java 7, the time complexity is O of n. In these newer versions, substring creates a new char array and copies the relevant characters from the original string into it, leading to a linear time complexity. Question 22. What is the difference between string.valueOf and toString method? Now both of these methods are used to convert any value into a string, but string.valueOf is the safer option. This is because if you accidentally pass null, it won't crash, it just returns null. But if you call toString using a null reference, then Java will throw a null pointer exception straight away. Question 23. Guess the output of the following program. We have a string s is equal to a, b, c, and we are splitting this string using the split method, and we are using comma to split it. Now the result we are storing in a string array, and in the end we are printing the length of that array. So the options are A3, B2 or C4. So the correct answer is A3. Now the split method breaks a string into pieces whenever it finds the given delimiter, in this case a comma. So the string A, B, C gets split into three parts A, B and C, and they are stored in a string array. Hence the length of the array will be 3. Question 24. Guess the output of the following program. We have a string s is equal to a, b, c. And again we are splitting it on the basis of comma, and eventually we are printing the length of the array. So the options are A6, B5 and C3. So the correct answer will be B5. Here we have multiple commas in between characters, and that means that empty strings get created in those gaps. So the string A, B, C gets split into 5 parts: A, then empty string, then B, then empty string, and in the end C. And Java does not remove empty spaces automatically that are in between the string or in the beginning. So all the pieces, including the empty ones, count, giving us a length of 5. Question 25. Guess the output of the following program. We have string s is equal to a, b, c, and again we are splitting it on the basis of comma. So we need to tell the length of the array. Options are A3, B4 and C5. So the correct answer will be A3. Now this is because in this case we have empty strings in the end. Okay, the string A, B, C, should have been split into 5 parts: A, B, C, and then 2 empty strings in the end. But Java removes the empty spaces that are there in the end. Hence only 3 parts are there: A, B and C, and therefore the length of the array will be 3. Okay, so the important thing to learn here is that if there will be spaces at the end of an array, then Java will remove it whenever we are using a split. Okay. Question 26. Guess the output of the following program. We have a string s is equal to a.b.c, and this time we are splitting it on the basis of dot. And in the end again we are printing the length of the array. Now the options are A3, B5 and C0. So the correct answer will be C0. Why? Now this is because internally split uses something called regex. And in regex, a dot does not mean dot. Dot means match any character. Okay. So it splits on every single character in the string. Hence everything gets removed and you end up with an empty array and the length becomes 0. Alright, question 27. Guess the output of the following program. Again we have a string s is equal to a dot b dot c, and this time again we are splitting it on the basis of dot, but we have used escape characters. Okay, these two lines, these are the escape characters that we have used, and in the end we are printing the length of the array. So the options are A3, B5 and C0. So the correct answer this time will be A3. This time we have used escape character along with the dot. By escaping the dot, we tell Java to treat it as a literal dot. So now it properly splits on the dot characters and gives us A, B and C. That makes the length exactly 3. Question 28. Guess the output of the following program. We have a string s is equal to hello, and we are calling the toUpperCase method using this string. Then in the end we are printing this string. So the output will be hello in lowercase. Now this is because toUpperCase method does not change the original string, as strings are immutable in Java. So s.toUpperCase generates a new string hello, but since we didn't store it in any variable, so nothing is pointing towards it. The variable s still points to hello in lowercase, and that is what gets printed. Okay, question 29. Guess the output of the following program. We have a string s is equal to hello, and then we do s is equal to s dot toUpperCase, and then we are printing s. So this time we are assigning the result of s dot toUpperCase back to s, and since strings are immutable, toUpperCase creates a new string hello and returns it. Now by writing s is equal to s dot toUpperCase, we update the reference. So now s points to the new uppercase string. Hence when we print it, we get hello in uppercase. Okay. Question 30. Guess the output of the following program. Now we have 4 different strings, s1, s2, s3 and s4, and each of these strings have hello inside them, but they also have spaces. Okay, so in s1 we have leading spaces, in s2 we have trailing spaces, in s3 we have both leading as well as trailing spaces, and in s4 we have spaces in between. Okay, so now we are calling the trim method using all these 4 strings and we are printing its result. Okay, so the correct answer will be hello without space, then hello without space, then again hello without space, and in the end he, then 3 spaces, and then LLO. So the underlying logic is very simple. Trim removes the leading and trailing spaces, but it does not remove the space in between. Okay, that's the logic. So this is it. I've covered the top 30 string based interview questions, and what I've done in this video is that I've tried to cover all the important topics that are generally asked around strings, and I've created questions around them in creative ways. Okay, so this is a very good video for you to revise, and if you want more videos regarding Java core interview questions, please subscribe the Curious Coder.